Really? Yeah.
No, it's funny. I'm also you were nice.
Am I speaking here?
No, you can speak like normally. Yeah, it's just it's a really good microphone, so
Gotcha.
it's just
Right. Hey everyone, thank you for coming to Polygon's first workshop. My name is Rahat. I'm a full stack developer advocate here at Polygon. I'm going to be teaching you guys about how to build a full stack dApp on Polygon today. So we're going to go from doing some smart contract code all the way to doing some front end code. It's going to be some live coding. So I'm going to need everybody to help me pair program because I'm going to have a lot of typos. So you're gonna have to keep an eye out for that. And yeah, so again, a little bit about me. I'm Rahat, developer advocate about Polygon. Previously been a front-end engineer and a Solidity engineer in past jobs. Sort of an indie hacker / Web3 enthusiast. These are some places you can find me. The code for this live demo will be available on my GitHub later on tonight. So you can definitely take a look at that GitHub for more info there. But first, what is Polygon? Some of you might be familiar, some of you might not. We're the leading platform for Ethereum scaling and infrastructure development. What does that mean? I kind of don't view us as like a separate chain to Ethereum or anything like that. We're building on top of Ethereum, we're scaling Ethereum, making it easier for a wider variety of people to use. So we offer a lot of different solutions, different things like ZK rollups, optimistic rollups, side chains, and more. Today's focus is going to be on our proof of stake blockchain. Which is an EVM compatible blockchain, meaning anything you do on Ethereum, you can do over here on Polygon. Our native token is Matic as opposed to ETH. We're super accessible and sustainable. What does that mean? Sustainable meaning we're committing to being completely carbon negative. You can take a look at our green manifesto, which was put out a little bit earlier this year, but we're one of the first blockchains to be completely carbon negative. So why should you build on the POS chain? Speed, 65,000 transactions per second, pretty fast. You can still leverage Ethereum. You can conduct transactions on the proof of stake chain, bridge assets back and forth to Ethereum as needed, and save on costs. It's approximately 10,000 times lower costs per transaction than Ethereum. It's a lot. So that is the full amount of slides you get from me today. If you enjoy slides, I'm sorry, I don't enjoy slides. So the rest of this is going to be live coding. I do have some notes here to make sure I don't screw up too badly. Make sure that stays on. Cool. So what are we building? We're going to be building a full stack dApp. It's called SageEM. It is a journal or like kind of like a live forum type app where you go to a website, you leave somebody a message. We're going to start off with the smart contract. So let's pull up my VS Code here. I've already scaffolded out a couple of different things. Mainly, I've gone ahead and started this like hard hat starter code So I use hard hat just to scaffold out like a basic contract. And what I'm going to be doing after I fill out this contract is using this contract inside of this Next.js application, which is just a React framework. So there will be some front-end code that we go over. I'll try to speed through that part a little bit because that can get a little much. But we'll start off with our contract. Basic kind of contract, I'm just identifying that this is a MIT license using Solidity above 0.8, and I'm importing this OpenZopping contract called ownable.sol. Basically means that when I write this contract, I can specify that somebody owns this contract. Why is that important? We'll see in a little bit. But we get started. Contract SayGM is ownable. What does that mean? I am inheriting everything that ownable gives me. I'm going to create this string called prompt. So I'm going to have a prompt on my dApp that kind of like lets people know how they should respond to my guest book. So just to start things off, we'll just say prompt is a string called SayGM. And that is like the initial message that people will see when they come to my dApp. I'm going to create an event. So I'm going to be emitting an event whenever someone decides to like actually come and SayGM. So how do I work with events in Solidity? The event, we're going to call this a new answer. We'll look at like people answering our prompts or proposals as we call them answers. So this is going to be a new answer, and it's just going to have an address, which is going to be indexed. This just means that later on I'll be able to search by this address. We're going to call that address from. So this is just a from person. And then we're just going to have a string called answer. Nothing too fancy. We're also going to have a struct with called answer, which is going to be more or less the same thing. Address from, as well as string, which is an answer. Cool. If you come from a background in like, say, Python or anything like that, structs are very similar to dictionaries or like objects in other languages. What's going on here?
Line 11.
Line 11. I mean, that is a comment. Let's see what's going on. Oh, there it is. No, that's not it. Yeah, that was it. I forgot a comma. Trailing commas. Worst thing ever. Anyway, so we've got our event, which is a new answer, struct of an answer that is going to be feeded into this event. I'm going to create an array to actually hold all of our answers. What I want to be able to do is actually display all of my answers at some point. So I'm going to create an array. It's going to just be an array of answers. So answers, this just means I've got an array. It's going to have this, a bunch of structs inside of it that follow this answer format. We can have a constructor. I don't know if we're going to really use it, but we'll just leave it in there for now, just in case. Cool. So this is just some of my initial information. Let's start writing some functionality in this. First thing I want to do is like set a prompt, right? In case I don't want it to say SayGM anymore, I want the owner of this contract to be able to change what the prompt is. So that's why I imported that ownable thing right over here. This allows me to actually specify and use a modifier called only owner that says, okay, there's this specific function here. It might be public, but I only want the owner of this contract to be able to execute this function. So that's the function we're going to write now. We're going to call it set prompt. Okay, function set prompt, and that's going to be, okay, it's going to take a string in memory, so we're not going to like save it anywhere. We'll call it new prompt because we already have like this string prompt up here. That's like a default. And what we're going to say is that this is public, but we're going to call the only owner modifier, which is what we inherit from ownable. Now, only the owner of this contract, so whoever actually deploys this contract is the only person who can call this function. So what I'm going to do here is first create an answer. Wait, no, this is set prompt, sorry. So yeah, this is just going to be pretty simple. We're going to take the prompt and set it equal to the new prompt, nothing fancy. What I also want to do, so, imagining we already have this functionality in here, there's probably going to be a bunch of answers if I ever decide to change the prompt later on that might be in response to, say, GM, right? So maybe we want to clear that array out anytime we update the prompt. So to do that, we'll use this delete keyword, and we can just delete answers. What that does is just take the answers array, empties it out. So this is kind of like a whole reset functionality. We're giving only the owner of this contract. Cool. Now, let's do our answer function. Answer function is also going to take a string in memory, and we're going to name it input. It's going to be a public function. Does it need to return anything? I don't think it does. No, that's fine. So we're going to create answer struct and shove it inside of this array. When we do that, we also want to emit an event that says that I went ahead and created this answer. The reason for that, we'll see a little bit more like later on when we try to use this on our front end. But it takes a while for us to do like read actions on the blockchain. A way to get around that is using something like the graph to speed that up a little bit. But reading is really, really slow. So we're going to emit an event that says, hey, we did this thing where some information was added to this array. Then we're going to take that information and showcase it on our UI. So got this function answer. So it's going to go answers.push, which is just adding a new thing into the array. And let me see. We want to call our answer struct. So the answer struct is going to take two things. Message.sender. Message.sender is just who is currently interacting with this contract. Give me their address. That's it. And the input that we declared as an argument up here. So we're taking the message.sender, the input, that is this struct that we have up here, the address that's from, the string that's an answer. We're creating the answer struct out of it and then pushing it inside of this answers array. Now, when we do that, like I mentioned, we created this event. We want to make sure that our UI can actually read that some event happened. So to actually emit that event, we say emit new answer. And we're going to just once again put in the message.sender and the input. Same thing we did up here, it's just we're sending now that information to this event that happened on the blockchain. Cool. So now we have a way to fill answers. We have a way for our our contract owners to actually reset and update everything. Let's add a couple more. I think we just need a way to get all of our answers. And then we'll also do one for getting, let's see, the prompt. Cool. So we'll just say a function get answers. And that is going to be an external function, which is a view, which means we're just reading some stuff. We don't want to use any gas. It's going to return, we're going to use this returns thing. It's going to return that answer array in memory. Cool. And This like definition is very long, but the actual function is just going to return answers. Nothing too fancy. And we'll also do another one for getting the prompt. So function get prompt. Prompt is going to be also an external view. Returns just going to be a string in memory. And that is just going to return the current prompt. Cool. So these are just going to be the functions that I'm going to be calling from our UI on the front end. So again, nothing huge going on. Just to recap a little bit, I have the string prompt that says say GM. This is the prompt that I'm going to be showing to users when they first open up my dApp. I'm tracking some events for whenever they actually answer that prompt. That answer is going to be in the form of their address and whatever input or string that they supply. That's going to be saved inside of this answers array. We have the set prompt functionality for the owner of the contract to be able to change the prompt in case they don't want it to say GM anymore. And whenever they change the prompt, it's going to delete the answers so that whatever we display actually makes sense for the prompt. Function answer, this is what the user will call when they actually want to answer us. And this is just creating a new struct with their address and whatever their input is and putting it into that array. This is that actual functionality that happens over here. And then a couple things just to view information. Get answers is just going to give us the list of all the answers. Get prompt is just going to return the current prompt. Cool. So let's deploy this. So I'm not going to show you my environment variable file, but essentially there's two things that I have in here: a private key for my the wallet that I'm using to actually deploy, and an RPC endpoint that I got from Alchemy. Alchemy has some cool, like you go on, you sign up for an account, and I'm using an RPC endpoint for the Polygon Mumbai test network, so I can actually deploy this on the Mumbai testnet. And we'll take a look at our hard hat config. Very bare bones, nothing much going on. I'm just using this .env to make sure I get the variables from my env file and specifying the solidity version. And I'm just specifying one network, which is our Mumbai test network. The URL is going to be that testnet RPC, and it's going to be using that private key just to make sure I go ahead and put that in there. I'm just going to show you real quick polygonscan.com. Polygonscan.com, very similar. Etherscan.com, same thing, same concept. It's a block store. I am currently connected to the Polygon, I think, mainnet. Let's go to the Polygon testnet. Actually, you know what? We'll stay on testnet, mainnet for a second. But you can, if you needed to add the Polygon network, you can go to polygonscan.com, add it down here. You can also go to Mumbai.polygonscan.com, and here, this is the testnet explorer. Same kind of concept, you can add the Mumbai network to your MetaMask down here. If you needed to get test tokens, you can go to Polygon Faucet. As faucet.polygon.technology, and you can head over here, grab your wallet address, copy and paste it into here, request some Matic tokens. I think it gives you like 0.5 or something like that, I don't remember, or 5, somewhere in that range. Having some issues switching over. Okay. Might just mess around and put this on mainnet if that's going to do that. But let's see what happens. So this is the consequence of live coding. There's always external factors. So I am just pulling up my terminal. I'm in my contracts file. I'll bump this up so you can see it. But since we've got this like hard hat config already written out for us, what we can do is npx. Oh, before I actually do that, let me show you the script that actually deploys everything. This is a script that will actually leverage hard hat to do the deployment for us. It's just a bunch of boilerplate code, took it straight from the documentation, and just took out some of the excess stuff that we didn't need. But it's going to essentially grab that contract, deploy it, and give us the address that it's been deployed to. If there's an error, it'll print out that error. So to get that going, the script that I run is npx hard hat run scripts deploy. And I'm just going to specify that the network is going to be Mumbai. So if you've ever deployed something using hard hat on Ethereum, works exactly the same way. You're just passing a flag for Mumbai. If you were to put this out on the Polygon mainnet, you would just specify that, which would be Matic. So hopefully this works. If not, oh, okay. Line 15, string answer. Let's see what happened there. Wrong place. Do I not want that? Okay, that seems good now. Let's run that again. Okay, there's another comma or something. Line 21. Let's see. I was warned not to do any live coding. I didn't listen. Maybe not. Okay. All right. Let me just double check my notes, see if I did something different than what I had previously done. Don't think I did. But to just save myself real quick, I did have this written out in Remix. So I'm going to copy and paste this code over just to be on the safe side. It's the same code, just properly written without any typos or trailing commas. I think I copied instead of pasting. Okay. So yeah, just the same code, a little bit more comments. You're also using like nat spec over here just to specify parameters and like what this function does. This is something definitely recommend doing when you're writing out Solidity code. Nat spec is a type of comment that is actually can be read by like the Solidity engine. So if you're familiar with like TypeScript and JavaScript, it's kind of like an additional type checking mechanism. So if I specified that this function needs an argument called new prompt, and I didn't have this new prompt in here, like so I would get an error from Solidity saying, hey, you didn't put a new prompt in here. So it's a nice little way of type checking stuff. So I think I only wrote that for one function. Definitely write that for all your functions. Cool. So it's clear. Let's do that again. It's taking a little longer, so I feel like yes. All right, our contract has been deployed. Let's take a look at it on Polygon Scan. It's going to be on mumbai.polygonscan.com. Sometimes it does take a second for the block explorer to actually catch up and propagate the data. But since we were given this address, I'm fairly certain we're good. Okay, we're good. Contract was created 28 seconds ago. Awesome. So we've got our contract. Let's take a look at our front end now and see how we can hook things up over there. Ooh, before I continue, we need to fill out this ABI.json utility that I put out in the front end. What is the ABI.json, you might ask? Let me grab that and I will explain that in a second. Is that in here? This is it, right? It definitely seems like it. Yes, okay, we're good. We're just gonna copy this and put that in here. When we're interacting with a smart contract on the Ethereum network from a front end, generally, if you were to interact with some backend service or an API, you might use like some sort of a fetch HTTP request or something like that. Doesn't exactly work the same way when you're trying to interact with the blockchain. You need some type of like, I like to call this a map, not like a computer science map, like a Dora the Explorer map. It's like, it tells you what are the inputs that are available on this contract. What are the different things we can do on this contract. So you'll see there's like the inputs here. You have like the new answer stuff. Some stuff that we inherit from the ownable contract as well. So this basically allows us to like tell JavaScript like, yo, this is the functionality you have for this contract. So first thing I'm gonna do is grab that contract address before I forget to not put it in here. So contract address. So this is my main index file of my React application. Right now, it's just running here. Just message says hello Miami, nothing fancy. First thing I want to do is add some type of like connect wallet functionality so I can gain access to the user's wallet. Sounds really weird when you say it like that. Get my notes up because this is going to be a lot. So I'm importing use state from React. It's just for this is just a React hook for tracking the state of my component. I have another component called the GM form. This is going to be a form with some inputs that the user will actually be able to add those inputs in. We'll take care of writing that in just a bit. But first, I'm going to add in a little bit of state management here. So I want to be able to grab the person's address. So address, set address. This is a React thing where I'm just tracking the address and saving it into state. It's going to start off as like an empty string. Once I have the address, it's going to update that to be the string that I want it to be. Next thing is this GM contract. So the actual GM contract functionality is going to be also saved into state here. And that is going to start off as an empty object. This part doesn't matter all too much, but this part here, handle wallet function. So we're going to create a function called handle wallet connect, and this is going to actually connect to our user's wallet. It's going to be an asynchronous function, so we use an async keyword, and we're mainly going to be interacting with someone who has a MetaMask wallet, browser wallet. If you wanted to extend this to make sure you're kind of hitting people who have mobile wallets, hardware wallets, etc. I definitely recommend looking at something like RainbowKit, which recently came out. which has like a whole bunch of baked-in functionality for just connecting to, I think, pretty much every wallet imaginable. I think it uses Wallet Connect under the hood, which provides all of that connectivity. Cool. So for now, we're just going to focus on MetaMask. And to do that, what MetaMask does it injects an Ethereum object. I can never spell this correctly. Okay. Into the window. So we're just going to pull that out of the window. And we're just going to say if Ethereum exists. We're going to do some stuff else. We're going to alert. Please install MetaMask. So if they do have MetaMasks, this will go into this if statement. And we're going to create a provider that is given to us from Ethers. Ethers is a library that I imported from up here. Ethers is going to be what helps us to actually like start interacting with the user's wallet, as well as interacting with the blockchain from our front end. So we create a new Ethers provider. This is again from just copy and paste from their documentation. So ethers.providers.web3 provider, and we're going to pass it the Ethereum object. And now we can start interacting. So we can do something like await provider.send and provider.send ETH request counts. I'm going to explain that in just a second, but this line of code right here essentially requests permission from the user's wallet to actually connect to our dApp. Cool. Last thing is we're going to get the user's address. So provider.getSigner is going to give us information about the signer, which is the person actually interacting. We can do something like const address, or yeah, const my address equals await signer dot get address. That's going to get the address of whoever is currently interacting. We can set the address state to be that my address. And finally, we're going to also connect to our contract. So we can start using some of the functionality there. So const connected contract. As you can see, I just can't spell. That's going to be new ethers dot contract. And this method takes in 3 arguments. First, that contract address that I have up here. Next is the ABI. So that the map that we were talking about before. So it's ABI.ABI because in this ABI.JSON, I have a specific ABI key in there. That's specifically what it's looking for. And last thing is the signer. Giving it all this stuff, I can now take my connected contract. We'll call it set GM contract and provide it that connected contract. We're going to take the object and methods that come from this connection and pass it down to like our form component, which is going to do the actual like communication with our contract. So now that that's done, I'm going to change this up a little bit. So let's do something like this. If I have an address, then I'm going to just display an H1 that says, hello, whoever you are on this address. Otherwise, let me wrap that in parentheses. Otherwise, if I don't have an address, I'm going to display this button. Just going to say connect wallet. On click of this wallet, we're going to run the function handle wallet connect. Okay. See if this works. So far, nothing changed. Okay. Wrong thing. Right, running my front end. Okay, cool. Connect wallet is here. Let me bump that up. So hit connect wallet. Wonderful. Okay. Just so you can see the full picture, I already have my wallet connected to localhost 3001, which is why I just grabbed my my address. But let me go ahead and disconnect. So you can see the full kind of picture there. Disconnect. Have I disconnected? Still connected. Disconnect. Let's refresh, hit connect wallet. I'm connected on my other wallet. Sessions account. Let's also disconnect from here. There we go. So if this is the first time that you give permission to this website, MetaMask will pop up like this. Hit next, connect, and great. Now we're saying hello, address of whoever this person is. So we've got that going. Wonderful. Let's add in some functionality for our form. So rather than doing this like hello address, I'm going to want to do some stuff in this form. So in this form, I'm going to be using a couple things. I'm going to be using use state from React as well as use effect, which again, we will go over in a second. How much time do I have? Do we have enough time? Okay. So from React, I'm going to export default this function, which is just going to be a component. The GM form. And the GM form is going to take an address and a GM contract as props. Cool. There's going to be multiple pieces of state that we handle in here. For now, I'm just going to put in the answer, as well as setting the answer. And that's going to do this use state. Once again, I'm also going to have a prompt and set prompt. I'm going to add some more state in just a second, but let's actually write out our form. So this is going to return some JSX. All right, I'm going to move this like hello that I had in here over there. Address. Let's just make sure that's working. So instead of the H1, we're going to be importing the GM form. And the GM form, and take the address, as well as what was GM contract. Looks like we're good. Just to be sure, say like hi. Yeah, okay. So that's connected properly, wonderful. Let's actually write out a form. This is just going to take one input. Put a label in here. HTML is still part of Web3. Answer, input, couple things inside this input. There's going to be the value of this input is going to be whatever the current answer is. So starting off, it'll be nothing, just an empty string. And then on change, which means as we're typing, we're going to pass the event of us actually like typing. And we're going to say set answer is going to be event.target.value. So whatever we type in is going to be saved in state. Say the type of input is just a text input. The name is answer. And we're going to say it's required to actually submit this form. And then we're going to put a button here, which is going to be our submit button. Type equals submit. We're going to just say GM. Cool. And now when we handle submission of this form, so on submit, what we want to do here is, let's get past that event. And that event is going to be passed over to a handle update, which we're going to write in just a second. So we're going to call it handle update prompt, handle update answer. So let's write that function up here. Handle update answer. What is this going to do? The first thing I want to do is grab that event that I get and do this event.prevent default. The reason we're doing that is because the default behavior of an HTML form is to refresh the browser, which we don't want to happen. So that will prevent the native browser behavior there. Okay. And next, I'm going to wrap everything we do here in a try catch. So what we're going to try to do is connect to our contract and update or add an answer based on whatever the user inputs. So what does that look like? We're going to do const update transaction. So whenever you interact with the blockchain and do anything where you're changing any type of state, changing any type of, or just like adding any data to the blockchain, it's called transaction. And the more I think about it right now, there's a lot more front end code. Probably should have not done the front end live coding. So I'm going to copy and paste what I've got over here. Is my cheat sheet. Let's see. As you can see, there's a lot there. So rather than me typing all of that out, I'm just going to tell you what it does. And for the sake of time, I'm going to use a previous version of this contract that I deployed. To VS Code. All right, so let's talk about this GM form. bunch of state that I'm holding in here, answers, prompts, new prompts, and the list of answers. Let's go down to the actual, actually, let me just save it and show this to you. Oh, what's going on here? I think I probably have another idea, a very crazy idea. Will this work? I feel like it will. Yes. Okay. There's an earlier code I wrote that I know works. So answers, prompts, new prompts, answer lists. Let me show you what this looks like over here. We hit connect wallet, method get prompts, data. Oh, let me just, okay. Do the same thing over here. Trying to get back to like an older contract address to make sure we have the correct things kind of working with this version of the code. There you go. Okay, it's 3,000. Can't resolve. Oh, okay. Let me get rid of that. Okay. So this is a working version of this contract, just for the sake of time. But essentially, I have this hello address going on, which is the connected address. You'll see here, I have this please say hi message. And that was because in this version of the contract, I set the prompt to be please say hi. So how am I actually getting that from blockchain? If we go into our GM form and scroll over to this use effect. So use effect is a React concept. Essentially, this is you put some code inside of this function and it runs at a certain time during a certain like effect or event. In this case, I'm running this use effect whenever my GM contract changes, which is only going to be one time ever, which is going to be during when this component actually renders. So I have this function here called get prompt and answers. Get prompt and answers, as the name suggests, gets all of the prompt and answers. Get prompt up here, I'm going into my GM contract and calling the get prompt function. If we remember, in our contract, we have our get prompt function, which just returns a prompt. So that's happening over here. I'm awaiting that to finalize, and then I'm using set prompt to get to take that string, save that into state up here, and then I display it in my UI down here, which is this H2 of prompt, and that is where the please say hi is coming from. Cool. Next up, I want to make sure that when someone says something, it displays. So hi from Miami. Hit say GM. I hit say GM, MetaMask pops up. This is going to cost some very small amount of Matic, 0.000297. That's like a fraction of a penny, I think, right now. Confirm. In my console, I'm like logging out everything that's happening. So it's answering, waiting for the transaction. In an actual like production environment, you probably want to display something to the user instead of like a console log, maybe like a spinner, a message, something. But it looks like the transaction's complete, it's been answered. I've got some information about this here. Waiting for it to actually show up. Okay, cool. So hi from Miami. This message came from my wallet, which is also recorded here. If I were to change my wallet, make sure that works with a different wallet. Go to account 2, Hit connect. Hello from another wallet. Say GM. Again, well, that's going to be going through, but like, what is that calling? It's calling this like this answer function, pushing like my information. Again, the message.sender is just my wallet address and the input into the struct, which is popped into this array or pushed into this array, popped into something else. When that happens, I was hoping it would happen already. Cool. Hello from another wallet, and you'll see my other wallet address is saved here. So it works. We're saving a specific wallet that is interacting with this contract thanks to the message.sender value. So I'm pretty sure I did not deploy this from this wallet. So if I try to do a new prompt, it shouldn't work because I'm not the owner of this contract because I switched my wallet. So instead of please say hi, we're going to send this back and create say GM, update prompt. Shouldn't work, but it should have given me an error. At least I know it's not working. That's good. Okay, here's the error. Hard to read, but if you go through all this gibberish, you'll see that ownable caller is not the owner, which is correct. I'm not using the wallet I used to actually deploy this, which means I cannot use this new prompt function. That works good. Let's switch back to the other account. And now if I do say GM, update prompt, MetaMask pops up, cool. It's actually allowing me to go through with the transaction now, hit confirm. And yeah, as we're kind of, I'll let that basically like go through, but the rest of the code on the front end essentially is also listening for those events. So to listen for an event, I use this like GM contract .on. So that .on functionality takes two arguments. First, the name of the event. So I named that event a new answer in my contract. And then I provided a listener function. That listener is up here. Listener is going to take a from value, so the from address as well as the answer. And it's going to just mutate my state and update it so that it includes that new information. That way I don't have to like rerun the entire like get prompt function every time I want to display all of my, get answers every time I want to display all my answers, because it's going to take forever. And awesome. So this update to say GM, all of the things inside of the array were deleted, which means all of our functionality is working. And it probably would have taken me another hour to write all that front end code. So probably a good thing I didn't do that. Cool. So main takeaways really from that is just that, deploying onto Polygon does not take anything more than one line of configuration, getting an RPC endpoint from something like Alchemy and Fura, and just putting it out onto, a different endpoint, as well as when you're deploying, let's say via hard hat, passing a different flag. Otherwise, Solidity works the same. Anything you import from OpenZeppelin works exactly the same. Everything one-to-one matches great. So yeah, would love to, if you have any questions, open it up for that. I know that was a lot. Yeah. I'm sorry? Oh, so for like getting like the Polygon Mumbai testnet stuff. So, or maybe I'm not understanding your question. Oh, for like other wallets? Yeah, so I'm using Ethers, and the way I have everything set up, this code is only compatible with like a MetaMask wallet. So if you wanted to make this compatible with other wallets, I believe it's called the Rainbow Kit. Rainbow Kit. Yeah, it's from Rainbow. If you've used like the Rainbow Wallet, that mobile app, it's from those folks. They recently put out this Rainbow Kit UI thing where you can It's a React library, so it works with any React framework. You pop this in. It has basically everything kind of like out of the box ready for you. Connect to a Coinbase wallet, connect to MetaMask wallets, connect to mobile wallets, connect to hardware wallets. I think it's just like a couple lines of configuration and whatever you want. It's kind of like up there. Super cool, super. Yeah, definitely if you're building something like a marketplace, you want to make sure your app is as accessible as possible. If you do it the way that I kind of demonstrated, you're only servicing people who have a MetaMask wallet. So using something like this would be good because then you have a wider variety of people to actually use your dApp. I don't think there's really a limitation. I think as long as, I think one of the underlying technologies is Wallet Connect, which I think connects to like everything. So whatever Wallet Connect connects to, you can connect to it. Any other questions? Cool. I will be around. I didn't bring swag with me right now, but I have a booth kind of like back there. I will be around tomorrow. If you want to talk, ask any more questions, talk about Polygon, pick up a shirt, one of these hats. Yeah, that will be available tomorrow. My friend Siraj is doing another workshop tomorrow, which is going to be on building your own DAO on top of Polygon. So this was kind of meant as a primer for like just basic sort of Solidity. He's going to take it a little bit further and give you like another use case of like building a DAO on top of Polygon. So definitely recommend checking his workshop out. I think that's happening tomorrow morning.
You said building a DAO.
Yep. Cool. Right. Thank you all. So I will post it on my Twitter. You can also go to github.com rahat-ch, or on Twitter, it'll be Rahat codes. Yeah, so RAHAT codes. I'll tweet RAHAT and codes. And I will post that later tonight. I think there's a Discord too. I'll see if I can get it posted in there as well. Yeah. Yep. COD, yes. Codes. Okay. Cool. Awesome. Thank you all. I'm sorry. For workshops, I'll generally just do Ethers.js just because it's like the easiest to kind of like go through in the workshop sense, but like in an actual dApp, I would use something else. Oh, so it's
All right.
And what's your name?
John.
Josh. Nice to meet you. Right, codes. COD. Yeah. Right. How you doing? Thank you. Yes, definitely. If you're like one of the things, if you're already building in there's nothing new yet to learn. Every factor over. So they're going from like Ethereum to transactions. We're also, a lot of our adoption Some of our competitors trying to say this in a way that is not showing too much, but a lot of our competitors have like specific things like roll-ups, optimistic roll-ups, and things like that. We don't have just one solution. I showed you one of our solutions. One proof of stake blockchain. Yeah. So there's the proof of stake blockchain. We have optimistic roll-ups, ZK roll-ups. So I think we acquired like Hermes. So what Hermes is building on top of like transferring payments, that type of thing. So we're building on top of that, as well as like a couple of other ZK stuff that are coming out next month. There's one called Nightfall next month. But yeah, that one incorporates both zero knowledge groups as well as schools. Yeah. No, we specifically acquired Hermes, but there are other ZK solutions. Yeah, it's like ZK Sync. I'm not 100% sure. I haven't seen the specific version of this. We each kind of have our own versions. Yeah. It'll probably be some type of like those functionality. I don't know. They might have. I'm not 100% sure. There's like a bunch of dApps that kind of like build on top of Polygon. But that's yeah. Okay. Hey.
I'm doing well in person. Good to meet you. So I was just wondering where you got to like templated out repos for Hardback. So
Yeah. So the I think we should be like getting started. Or maybe go back to that. Right. So if you run that command npx path, it'll go through this whole like choose your option thing. I chose create a sample project and then the basic option. Yeah, and that'll just like give you all of the files.
do a lot of people just sort of like do that and work from there?
Yeah. You definitely don't want to write that from scratch.
Yeah, it seemed like a lot. So I was like, oh, what? All right, thank you.
Yep.
Oh.
You mentioned before that